Hello and welcome to today's webinar with the title Challenges and Solutions for PCB-based Power Distribution Units. We are pleased that you have dialed in and thank you for your interest. My name is Lea Michelberger and I am a sales consultant at Würth Elektronik ICS in Germany. You may already have had the opportunity to follow me on previous webinars, and today I am supported by my esteemed colleagues Julian Müller and Ludovic Frenon. Julian is product manager for PCB components and Ludo is product manager for e-mobility solutions. On behalf of Würth Elektronik ICS, we would like to thank you for your registration. We are excited to show you what we have planned for today. And before we start, I would like to introduce you to a few organizational details. Please note that you are muted during the whole live session. Of course, if you want to ask questions or do remarks, you can use the question function. Besides that, additional questions can already be sent via email to ics.webinar@we-online.com. The presentation will take around 30 minutes. Afterwards, we will answer your questions in the Q&A session, so feel free to grab a pen and write down your questions during our presentation. Of course, if there are too many questions and we cannot answer all of your questions during the webinar, we will answer the questions afterwards via email. In addition, we would like to give you some hints about the control panel in advance. In the top corner on the right-hand side of the screen, you will find various menu options. You can find the settings by clicking on the cogwheel. Here you can select the menu language and make changes to the audio and camera settings. With the question function under the icon with the question mark in the speech bubble, you can ask questions during the live session, which we will answer in the Q&A session afterwards. Now, as the organizational part is completed, we are going to start the webinar by diving into the agenda. And so, Julian, the stage is yours.
Thank you, Lea. A warm welcome from me too, and thank you for joining us in our webinar. What can you expect for today? First, I will introduce you to Würth Elektronik ICS. The second topic today is the transmission of current in power electronics. After that, we show you a case study with PDUs, connection technologies, and connection possibilities of press-fit technology. After all, we give you a summary and show further services. Finally, we will summarize the topics presented and answer your questions. Now we can start with the webinar Challenges and Solutions for PCB-based Power Distribution Units. At the beginning of today's webinar, I would like to say a few words about the background of Würth Elektronik ICS. Würth Elektronik ICS is part of the Würth Elektronik Group, which in turn is part of the Würth Group. The Würth Elektronik Group is divided into three divisions: electronic components, circuit board technology, and our business unit, Intelligent Power and Control System, or ICS for short. Our product portfolio ranges from power distribution solutions, electronic control units, and HMI solutions to HV solutions and PCB components. Basically, our expertise lies in the management of high currents associated with PCBs. We serve customers from a wide range of industries, from commercial vehicles to renewable energies and household applications. As a developer and manufacturer with our own electronics production facilities, we at Würth Elektronik ICS have experience in all aspects of power elements and support developers in finding the right solution and the right process. This includes both standard and customized solutions. As today's topic is challenges and solutions for PCB-based power distribution systems, In this webinar, we will take a closer look at power distribution systems with HV solutions and high current contacts. High current contacts are also known as power elements. They form the basis of power distribution systems. Today, power elements are a cross-industry standard for connecting the PCB. The basic function is to establish a reliable connection between the PCB and the component to be connected. Now we come to a short introduction to the topic. As the fields surrounding e-mobility are becoming more and more present, we have brought along an exemplary architecture of a battery-powered vehicle as an introduction to the topic. As you can see, there are several different consumers and they all need to be supplied with power. This challenge will form the basis for the entire presentation. A fundamental issue in power electronics is to bring energy into a device, make it usable and distribute it. This is where power distribution systems come in. They fulfill these tasks. The aim is to work as efficiently as possible during transportation and conversion, and to keep the transition resistance as low as possible. Now, Ludo will go on.
Thank you, Julian, for the introduction into the topic. We would now like to show you some practical examples in this chapter. We'll take a closer look to the power distribution system, which we call power distribution units, or PDU as abbreviation, as well as the associated components and connection technologies. First of all, we need to define exactly what power distribution in a vehicle actually means. The aim or function in an electric vehicle is to safely distribute the power in the vehicle and switch loads when requested. The second function is to protect the vehicle's electrical system and provide measured values to the control units. The third important function is to provide safe and easy access for carrying out maintenance work. Julian has already briefly described the usual architecture of a battery electric vehicles. I will now go into this in more detail. Typically, the electrical energy comes from the grid and is stored in the onboard battery by an onboard charger or DC charger, which is the charging phase. During the drive phase, the battery then supplies part of the current to various components or loads, such as an electric motor, DC-DC converter, or some auxiliary devices, for example, the blower or pumps. But how do you connect all these components? In all cases, the PDU is the part that makes possible to connect the various components together. But it is not only to connect the components, it also switches and protects them. As just mentioned, the basic issue is that you have to get the energy onto the circuit board. This can be achieved using various contacted methods. At the first level, we look at the interface between the PCB and the component using our power elements as an example. This can be contacted with the PCB using the options shown here. Solid and flexible press-fit technology are shown on the left. Free soldering technologies are shown from the center to the right. THT, SMT, THR. In the following, we will focus on THT soldering on the end solid press fit, as they are often used in practice. Then there is the connection of the power elements. Here there is the option of screwing, plugging, or welding. Now we come to the focused assembly options. Press-fit technology is solderless connection technology in which a pin is pressed into the plated through hole of a PCB. Press-fit technology is always used when high current needs to be transmitted or when particularly robust connections are required. Soldering technology makes it possible to assemble printed circuit boards with the smallest components. Solder is used to create a permanent connection between the high current contacts and the printed circuit board. Depending on the high current contact, there are various soldering options. A brief explanation of the solid press fit technology is now required. As already mentioned in the name, the pin used here is solid. The press fit leads to a displacement of material in the PCB, resulting in a gas-tight cold welded connection. To ensure high current transmission, the contact resistance of the press fit connection must be lower than the inherent resistance of the pressed pin. This is guaranteed if the contact area between the pin and the sleeve is at least equal to the cross-sectional area of the pin. Normally, 3 degrees of contact area on the side of the pin is sufficient. In reality, the contact area is even bigger than 3 degrees. We have illustrated this again here. The illustration on the left shows a pin. The plates represent the copper layers of the printed circuit board. The green line is the connection surface. Due to the pin geometry, the connection area is in the corner. The middle illustration shows a micrograph. Here you can see that the connection surface in the corners of the pin again. The red area corresponds to the 3 degree minimum requirement. As colored blue here, the real press fit zone is larger. This means that the contact resistance of the press fit connection is lower than the inherent resistance of the pressed pin. We can now compare this technology with soldering technology, which is often used to connect electrical components on a printed circuit board. There are two different interfaces in soldering technology. The first is the interface between the pin and the soldering material. The second is the interface between the soldering material and the hole in the PCB. These interfaces can be affected by contamination or oxidation, but process problem can also have a negative impact on the quality of the connection. The tin alloy used in the soldering material is also a poor conductor in relative terms. This is not the case with the press fit technology. Instead, there is a direct connection between the pin and the drill hole, resulting in a gas-tight cold welded connection without oxidation problems. This results in a lower contact resistance for this connection. On the slide, we have compared the contact resistance of THT soldered connection and the solid press fit. On the graphic below, you can see once again that we have two interfaces due to the use of solder connection. One is between the pin and the solder, and the other is between the solder and the PCB. With the solid press fit technology, we only have one interface between the press fit pin and the PCB. The use of solder material and the resulting additional interface in THT soldering leads to an electrical contact resistance that is approximately twice higher than the press fit connection. Here we have once again summarized the advantages of the massive press fit technology that are decisive for us. The cold welded connection as a basis enables high current carrying capacities of the connection as an excellent mechanical stability. The press fit connection also has thermal advantages. When using soldering technology, the solder must be heated and the copper tracks of the PCB are therefore exposed to heat. The PCB is not subjected to this thermal stress when using press fit technology. It can therefore be summarized that the massive press fit technology is particularly suitable for high current application and for use in harsh environmental conditions. This makes it a good choice for contacting the HV components of the PCB and OPDO. It's also a good basis for power distribution system. Press fit technology also offers us many advantages when developing a product and therefore expands our solution for PCB-based power distribution systems. One advantage is that the PCB can be assembled on both sides. This makes us much more flexible in terms of assembly and allows us to implement them in a relatively compact way. Specific power elements can be used to connect large cables or large components, such as fuses. Now that we have talked about connection technologies, let's move on concrete solution for power distribution system. To realize the three functions Julian mentioned at the beginning of the chapter, safe power distribution, protection of the vehicle electrical system, and safe and simple maintenance work, we need a PDU. In order to be able to guarantee these aspects safely, the components used must be securely connected to the PCB. We use massive press fit technology for this purpose, Hence the basics and background on press-fit technology in the last slide. As you can see, it's a compact and robust design that is embedded in a sealed die-cast aluminum housing. Various functions are integrated. You can see, for example, various fuses, a circuit for pre-charging or measuring sensors. The basic aim is to remove as many high voltage cables as possible from inside the PDU. The cable you see in this picture are only here to manage the low voltage signals. Another advantage is that this PDU is a complete plug-and-play solution. It means that you only have to mount it on the vehicle architecture and you can immediately connect it. Nothing needs to be adapted inside the box. Here another example of PDU application. In this case, we have integrated our CDM A16 controller that you can see on the top right side. This controller manages the CAN communication with the vehicle, read and transfer the voltage and current measurements, and switch the contactors. There is also on the right side the integration of an isolation monitoring device. This is an example of a smart PDU integrating some intelligence. I have just mentioned the basic aim of reducing the number of cables. Here you can see the classic before and after picture. This is a design we have created specially for one of our customers. On the left, you can see a PDU that was realized with wires and bus bar, and it's even relatively tidy. On the right, you can see our solution where the compactness is immediately noticeable. Many wires and bus bar between the components are replaced by copper tracks in the PCB. This solution reduces assembly times considerably, but more important, it significantly reduces the risk of wiring errors, poor assembly, or shortened insulation distances during the vehicle's service life. To increase the modularity of the components, we use design blocks for the PDUs and can be seen here. Design blocks are used to integrate typical components that are present in a PDU. They can be installed in the PDUs relatively easily and simply. A major advantage of this is that the components can be replaced relatively easily if they are broken. You can see some example of the integration of fuses and contactors here. For the contactor on the left, you can see the power elements in green. Those allows the power contacts to be screwed and connected to the circuit board. You can also see that small pins without soldering are also connected in the PCB to connect the coil and the feedback signals. Here you can see two different examples of connector integration. The left-hand connector is integrated into a right-angle power element, and then a screw is attached horizontally to maintain compression. The right-hand connector can be connected to a power element socket with the bus bar of the plug and the screw. A major advantage of this is that it saves the high voltage cables. And now we come to our last family of components. As mentioned earlier, PDU products are also important when it comes to the safety design of electric vehicles. Measuring the current and voltage can often be required in the system to manage battery load and power. On the pictures, you can see two different types of sensors. On the left side, the current is measured by a shunt bus bar mounted on a power element. On the right side, a Hall effect sensor measures the current flowing through the power element.
Thanks, Ludo. We have now moved on from the basic issue of power distribution to power distribution systems, the connecting technologies, and examples of PDUs. Ludo has just mentioned the design blocks, and here we go into a little more detail. The power elements marked in green can not only be used in fixed design blocks, they are also very flexible in their area of application. On the following slides, we will show you some examples of how you can use these power elements to apply power to the PCB. In the following slides, we will always start with one
Julian, I'm sorry to interrupt you, but there is Mr. Schirmann who is saying that audio is quite bad. Could you maybe move a bit closer?
Yes. Sorry.
Thank you.
So I hope it's now better. I will start from beginning from this slide. So in the following slides, we will always start with one or more components that are to be connected or assembled. On this slide, a busbar to board connection is to be made. So we want to mount a busbar to the PCB. Therefore, we can use a LF Power 1 power element. For your information, the LF stands for lead-free, so these power elements are also available as a lead-free version. We are completely flexible in the way we contact them. Both press fit and soldering are possible. This assembly is done in just a few steps. First, the power element is contacted with the PCB, and then the busbar is screwed onto the power element. In this case, we have shown a bush. Depending on the shape of the busbar, it may also make sense to use a bolt and mount it with a nut. In addition, or as an alternative, it is also possible to press the busbars directly into the power element, as shown in the picture below. This is often used when higher currents need to be distributed locally, but you don't want to use a thicker PCB. On this slide, the initial situation is that two PCBs are to be connected to each other, a board-to-board connection. At this point, it should be briefly mentioned once again that the options shown are only examples. There are many other options for connecting two PCBs together. On the previous page, we saw a screw connection. Here we see a plug connection. This is possible with the LF power basket. The LF power basket is aligned horizontally using an auxiliary rail. It is then connected to the PCB. The bolt, as the counterpart, is also connected to the PCB. Afterwards, the bolt can then be inserted into the LF power basket. This is used, for example, to connect several modules together. Here again is a plug-and-play solution. As a third example, I will show you the contacting of an IGBT module. This can be realized by using the LF Power 2 power elements. The challenge with the IGBT, for example, is that usually has to be mounted from below through the PCB. It should be noted that screws should not be screwed directly on the PCB, so that it is not stressed and does not suffer any damage. The LF Power 2 combination therefore consists of two power elements, the base element and the press fit element. The base element is first pressed into the PCB, and in the next step, the press fit element is pressed into the base element. The IGBT module can then be attached from below through the PCB. In this case, the compression only takes place between the power element, which means that the PCB material is not included in the compression chain. We have talked a lot about press fit technology in the previous slides, as it solves many problems for us, particularly in the area of power distribution system, and also fits in very well with the requirements of HV projects. In addition, the applications in the last slides are examples. Power 2 can also be used, for example, to mount other components and is not limited to IGBT modules. The message we want to get across is power elements can be easily contacted with the PCB no matter which assembly or connection method is used. On the previous slides, you have seen various examples of how components can be connected to the PCB with the help of power elements. The components and power elements shown here are only represent a small selection. Here we have listed the different product groups of power elements, and now I will briefly explain which power element group can be used for which use case. LF Power 1 is ideal for verticide and customizable applications. LF Power 2 is ideal for screwing through a PCB with high screw-on forces, such as shown with the IGBT module. LF Power Plus is ideal for increased torque requirements, low weight requirements, and automated processing. Power lamella is ideal for connection with Radsok connectors, and they are characterized by a high contact overlap of the lamella contacts. Similar to a power lamella is power Radsok. It is ideal for connections with lamella connectors and are also characterized by a high contact overlap of the lamella contacts. The LF power baskets are ideal for multiple plugging circles with the low plug-in forces, high position tolerances, and low weight requirements. Power Flex is ideal for combination of screw and fast-turn flat connectors and low weight requirements. The last product group is Power Cover. It is ideal for protecting power elements and serves as rotation and contact protection. You can also find all product groups and standard articles on our online platform, powerelement.com. As already mentioned in the application examples, we also offer LF, also called lead-free power elements. Due to various regulations and directives that classify lead as a hazardous substance, such as RoHS regulation, which is intended to restrict the use of these substances in electrical and electronic equipment, we at Würth Elektronik ICS have decided to develop a lead-free power element assortment. Product groups such as LF Power Plus or LF Power Basket are only available in lead-free versions. Other product groups such as Power 1 or Power 2 are available in both the original and LF version. If you have requirements that go beyond the standard items, this is also no problem. Whether it's customization of shapes, threads, pins, or other topics such as documentation or packaging, we will be happy to work with you to develop the right product for your project. To give you an idea of the design options available for power elements, in order to find solutions in the field of power distribution systems, we show you some sample articles here. These range from the insertion aids of nuts in the thread, which enables automatic screwing, cavities in the power element to save weight, to offset rows of pins for optimum positioning on the PCB.
Now we come to the summary about today's topic, challenges and solutions for PCB-based power distribution units. There are various ways to connect high current contacts on the PCB and thus lay the foundation for power distribution systems. We have identified solid spread fit technology as particularly suitable, especially for power distribution systems with high current application and for use in harsh environmental conditions. Within the power distribution systems, the flexibility of the high current contacts, board to board, bus bar to board, or wire to board, offers a wide range of options for solving challenges in the field of power distribution systems. In addition to the standard portfolio, we also offer you individual advice on your project from start to finish. Our support is not limited to the standard range. We are happy to work with you to develop customized products specially for your application. And now, bring your project. This service allows you to easily get in touch with our sales colleagues and engineers to discuss current projects with them. We want to help you to realize your ideas, regardless of whether you want to develop a new product or optimize an existing one. We are also happy to provide you with free samples and further information on power elements and printed circuit boards. You can easily access the samples and information via our online platform, www.powerelement.com. There you will also find additional features such as datasheets or CAD data. If you would like to contact us, you have various options. Firstly, there is a live chat where you will receive an answer from one of our colleagues in real time. You can also contact us by telephone or send an email to the powerelement@w-online.de. Now we are already at the end of the presentation. Many thanks to you, dear listeners, for your time. We hope that you were able to take away some interesting information. Leah will provide you information on what's next.
Thank you, Ludo and Julian, for sharing those insights today. Before we are moving on to the Q&A session, I want to remind you to the different channels you can contact us. If you have any questions in retrospect, don't hesitate to contact us via chat, email, or ask your account manager. Anyway, use all channels to contact us. Now we can start with the Q&A session. You can ask directly via the question window mentioned at the beginning. I'll try to answer or ask Julian or Ludo to answer your questions. And so please ask us all the questions you have, and all the questions which cannot be answered right now, we will of course answer afterwards via email. I will just start with the first question. What do I need to press in power elements? I guess, Julian, you might be the right person to answer that one, will you?
Yes. So there are no special tools are required to press in the power
I guess you
elements.
have to move again a bit more to your microphone.
A simple toggle press is sufficient. So and during the pressing process, the PCB has to be supported. So that is not stress. And to ensure that the power elements are pressed in straight, the pressing force has to be applied at a 90-degree angle to the PCB.
Thank you very much. But we also have these on the technology side or technology section on our homepage. So if you want to get more details, you can also look it up there. Okay, let me check the next question 1 second. What are the press fit forces for power elements with press fit technology? I guess Julian is also another one for you.
Yes, the press-in forces are up to 60 to 250 Newton per pin can be expected, but will, depending on the power element, the hardness of the PCB, the first surface, and the quality of the PCB. So, there are many options that are depending on the press-in forces. But with 60 to 250 Newton, you can expect.
Thank you. Next question might be if we have a certification for IATF, but I guess I will just answer directly. Yes, we have a certification for that one, as we are having a lot of projects in the automotive industry, and also you can find our certification on our homepage just for download, or of course ask us for it. We can also send it over to you. I will just continue checking the next question. Let me just check. Okay, what is the design process for our current PCB? Let me check again. What is the design process for high current PCBs around 500 amps? They are probably based on copper inlays. Can you describe the press-in copper bus bars a bit more? Who of you guys want to answer? Julian or Ludo?
I will answer. So the design process for high current on PCB, we are working with different layers inside the PCB with a thick copper thickness. So depending about the current application that we have, then we will design the copper tracks with different layers in order to get enough current carrying capacity. As soon as we are achieving the max that we can do on the PCB, we can add a bus bar, could be press fitted directly on the PCB, and you saw some pictures before, or could be an additional bus bar with power elements to transfer the bigger current track into the PDU.
Thank you. Next question would be, which PCB surface finished would you recommend for use with press-fit components? I guess sorry, I have to just do another question for that one. I guess there is meant the PCB surface in with using by the press fit components like on the same time with the power elements itself. But
Maybe additional things could be also used to the question before. So usually we are working, so as soon as it's coming to HV, we are working with PCB from 2.4 millimeter thickness or 3.2. And then we have copper layers about 1.5 micrometers. So 105 micrometers. That's the minimum requirements we need for the press fit technology into PCB.
okay. Question, let me just check. What is the maximum current on a PCB for a PDU or for power distribution unit?
So regarding the current, the max current on PDU, it's difficult to really say what's the max current. That's really depending about the different conditions. But as said, 400 ampere is really classical, 500 ampere, depending about the conditions, we can use a PCB or a PCB plus a bus bar as an hybrid solution. That's really depending the conditions, but it's in that range about 400, 500 ampere.
Mhm.
And additionally, by power elements, the current carrying capacity depends among for example, the dimension of the power element. A bigger power element with more material can carry more current than a smaller power element. But for example, larger power elements can carry up to 700 amps.
Okay, thank you guys. I just want to add that also if you have some unsureness in your system, just contact us. We will have a look, and of course, it is basically we are there for you to answer this question or to have a closer look into your application, of course. Next question. Are there design rules for high current PCBs available? Are they produced by Würth Elektronik? Are the press fit bus bars manufactured by Würth Elektronik as well? Design rules for high current PCBs.
So,
who of you wants to answer the question?
On our online platform, powerelement.com, there is a special technology page. So there you can see our design rules for PCBs and some further information how you can press in or solder the power elements on the PCB. So if you want more information, have a look there. And if you don't need, if you need further information, you can contact us via different channels.
Exactly. Thanks. So there's another question left. The question is if we are able to provide PDUs for fuel cell vehicles.
Yes, for sure. I show some example about battery electric vehicle architecture, but in a fuel cell electric vehicle, we also have to connect the energy coming from the stack. So this is basically an electric vehicle using an electric motors and then aggregates like we have. So that's typical, the same architecture with DC voltage, and we can provide PDU for that, no problem.
Thank you. So there are no questions left, I suppose. If you have any questions afterwards, of course, don't hesitate to contact us. As we are now at the end of today's webinar, I just want to thank you all for listening, for your time. I hope you enjoyed our webinar and it was a pleasure for me to guide you through. I would like to invite you to fill in our survey I mentioned at the beginning. Your feedback, of course, is always helpful for us to improve our performance for the next or the following webinars. As always, you will receive the documentation for the webinar from us shortly. And if you have enjoyed today's session and are interested in further topics, we'd be happy if you would sign in next time again. So thank you very much again. See you soon and goodbye.
Goodbye. Thank you.